Hello everyone, I Aparna Chauhan. First start with my brief introduction. I am an assistant professor in Pune University, Maharashtra, India, and PhD scholar from Symbiosis International University, India. So this is my mail ID. So today I am going to deliver a topic on performance of suction pile and plate anchor for floating offshore structures. So basically the offshore structure are used as the extracting the oil and gas from the earth crust to produce the renewable energy. So there are the mainly two types of offshore platforms. First is gravity load platform and second is the floating platform. So the offshore structure, the floating offshore structures are mainly classified based on the platform and its utility. The floating offshore for the wind turbines and second is the oil and gas extraction platform. So floating platform, which is there are three types of platform: the spar BO, spar submersible and tension leg platforms. So in spar BO platform that achieve the stability by using the ballast weight, and it generally used for the depth, water depth up to 3000 meter. The spar submersible or the semi-submersible unit is this type of platform is used for the water depth up to 300 meter to 2000 meter. Then tension leg platform is used for a water depth up to 2000 meter. So these platforms are based on the utility, based on the type of soil on seabed, and it also used for the system, that system which hold the anchor with the platforms. So there are the mooring system that hold the platform with foundation or anchors. So these are the three mooring system: catenary, taut and vertical. So catenary mooring system is the steel chain which is laying on the sea floor in advance of anchor, and benefit of this method is the angle of chain is close to zero. This taut line mooring system is having an angle of 30 degree to 45 degree with horizontal seabed. Then in vertical mooring system, the steel cables are used which is directly goes down to the anchor system and applies the vertical load on the anchors. So these are the catenary system generally used for the floating offshore structure. These systems are the part of the offshore structure. There in this my study, I studied the two types of anchor, but generally these type of anchors is used for the floating offshore structure. Some type of anchors are used to hold the ships or to hold some systems for extracting the oil and gas platforms. So these are the anchors: first dead weight anchor, drag embedded anchor, vertical loaded anchor, pile anchor and plate anchor. So in this study I did analysis for the suction pile anchor and suction embedded plate anchors. So suction pile anchor, which is closed at top and open at bottom. Thus this pile suction anchor is the hollow steel pipe. That diameter of pipe or pile which is much larger than pile. Generally pile which is used as the foundation of structure, and its diameter is generally very less. But here for the foundation of platform, floating platform, having the diameter which is much larger. It may be 3 meters, 6 meter, which depends on the capacity of that platform or the purpose of platform. So this anchor, which is embedded in seabed with the help of suction action. So this is the suction pile anchor, which work as a foundation of the platform. Then second type of anchor is the plate anchor, which is suction embedded plate anchor. The plate that is called as sepla. The sepla consists of plate anchor which is attached to the tip of hollow caisson, and the suction installation is very similar to that of the suction caisson. The additional under pressure is required to overcome the added soil resistance acting against the plate. After installation to target penetration depth, the caisson is withdrawn and leaving behind the vertical oriented plate. So that plate is used as again the foundation of the floating platform, floating offshore structure. So this image, the suction pile anchor used as the foundation for floating oil and gas extraction platforms. So this is the mooring system which hold the platforms with the pile or with the foundation. I am calling here foundation because it works as a foundation of floating platform, but actually it is the anchor. Okay, so here I did the analysis of two types of anchor, and I have taken the three types of soil bed for this analysis, and I did the analysis in two types of software. First analysis for the suction pile anchor in MIDAS 3D software, and plate anchor in Plaxis 2D software. That I have decided based on the literature. These are the parametric study for the suction pile anchor. So length to diameter ratio, which varies from 1.5 to 6, and the mooring position, that is called as pad eye position, that I will describe in later. So that percentages varies from 5% to 95%, and the load inclination angle, which is varies from 0 degree to 90 degree. The type of soil I have taken here for the analysis is dense sand, medium dense sand, and the clay soil. So this is the problem definition of suction pile anchor. The length L is a length of pile, D is the diameter of pile. This is the pad eye position, that varies from the 5% to 95%, and the load inclination angle, which varies from 0 degree to 90 degree, and the type of soil I have taken here. So pad eye position, for example, the 5% pad eye position, that is the ZCL by L. ZCL is the depth of embedded, or the depth of where the mooring points is provided, and the L is the length of pile. So that ratio is 5%. So as we can take, as I have taken the 5% to 95% pad eye position. So this is the property assigned for the soil layer analysis. The unit weight, Young's modulus, Poisson's ratio, angle of internal friction, and cohesion I have taken of three types of soil. Then I have taken some additional parameters here for the steel, or for the steel type of anchors, the pile and plate anchors, the Young's modulus, density, and Poisson's ratio. Then I assign the soil in MIDAS 3D software, which directly depend on the pile, type of pile. So I have assigned the soil here, and I have demonstrate the model here for the analysis. This is the pile anchor model, which is hollow, means which is not completely hollow, which is closed at top and open at bottom, and I have maintained the thickness of the pile also. And this point, green point, shows the application of loading. For example, this is the 75% of mooring position. So here I have apply some load for the analysis. So here in this study I have taken the Mohr-Coulomb model for this analysis in MIDAS 3D software. After analysis, I have taken the length of pile 6 meter and diameter 3 meter, and these are the pad eye position and these are the angle of loading, and I get the value of uplift capacity for particular pad eye position and particular angle of loading. So in this graph, in this table, we can see the 75% mooring position or pad eye position gives the maximum uplift capacity as compared to the other pad eye positions, and the 0 degree, which gives the maximum capacity. That 0 degree means it is the catenary type of mooring system, which the mooring lines are which is laying on the seabed. 22.5 degree inclination angle gives the 9000 kilonewton capacity. 45 degree angle, which also gives the 7000 kilonewton capacity, and 67 and 90 degree angle, which gives the very less uplift capacity as compared to other three. So these are the analysis, these are the some values which is I have taken from the software after the analysis. So from that this graph is generated from that table. From that analysis, I have taken the lots of L by D ratios, and from that L by D ratio I have decided that the 75% capacity gives the maximum uplift capacity. So I have choose some one particular point, that is the 75% pad eye position, and from that pad eye position whatever I get the uplift capacity that I have recorded for the particular loading angle, 0 degree, 22.5 degree and 45 degree, because 67.5, 66.5 and 90 degree angle gives the very less uplift capacity. So I have ignore that 2 points and I concentrate on 3 types of loading angles, inclination angles. So from this study I have designed the charts for the particular type of soil bed and a particular type of L by D ratios. So these are the design charts. These 3 charts is for the dense sand, and next 3 charts is for the medium dense sand, and next 3 again is for the soft clay. So anybody wants to take anybody wants to evaluate the uplift capacity of pile for the particular dimension of pile, then they can directly take it from these design charts. So these are all charts I have designed. Then the next type of anchor is the suction plate anchor. The suction plate anchor may be a circular plate anchor or the strip anchor. So this H which is the embedded depth of the plate, and B is the width of plate. So here I have taken the circular plate anchor, so D is the diameter of plate I have taken here. Again the inclination of plate, which is beta, which is varies from 0 degree to 90 degree again, and again I have designed some charts. That charts gives me the H by D ratio versus pull out capacity. So H by D ratio, which is varies from 0 to 12. H is the embedded depth and D is the diameter of plate. This analysis I did in Plaxis 2D software. So here the diameter of plate I have taken the 4 meter. So that is the much bigger plate I have taken. So this type of plate is used for holding the floating offshore structure with soil. So for that much type of diameter, for example 4 meter I have taken. So 4 to 4.2 meter diameter caisson is required to install that plate anchor at particular depth inside the seabed. So this analysis I did in Plaxis 2D software to evaluate the pull-out capacity of the plate anchor. So here I have taken the circular plate anchor. So from that design charts we can calculate easily the from H by D ratio for what will be the uplift capacity for the clay soil, for the medium dense soil, or for that assigned properties of soil that I have calculated here. So these are two types of anchor which is designed for the for the floating offshore structure, and I have designed some charts to calculate or to evaluate the pull-out capacity of uplift capacity of this of the anchor. So anybody having any doubts regarding this, they can contact me. I have provided the email ID on my first slide. So thank you so much. Thank you.